So now we are on the Module 12, the switch security configuration of the bridging course of SRWE. So the module objective is to explain how WLANs enable network connectivity. So this includes the introduction to wireless, components of WLANs, WLAN Operation, CAPWAP Operation, channel management, and WLAN Threats, and secure WLANs. So in these topics, so we need to describe WLAN technology and standards. So for the components of WLANs, we need to describe the components of WLAN infrastructure. So in the WLAN operation, so explain how wireless technology enables WLAN operation. For the CAPWAP, explain how WLC uses CAPWAP to manage multiple APs or the access points. So channel management, so this we will be describing it in a WLAN. And WLAN threats, we will also describe that. And secure WLANs, describe WLAN security mechanisms. Now we're on the first topic of switch security configuration, which is the introduction to wireless. So we will be discussing these points, the types of wireless networks, wireless technologies, and wireless standards organizations. So first of all, a wireless LAN or WLAN is a type of wireless network that is commonly used in homes, offices, and campus environments. So for the types of wireless networks, so we have, so it only it depends on, like I said on the LAN, on our first video, it depends on the range, and the range are and size. So we have the WPAN, WLAN, LAN, and one. So the wireless, here we have the example here, the wireless personal area networks. So it uses low power transmitters for short range networks, so usually 20 to 30 feet. So it depends on the size of range. So this has the shortest range or the smallest range. Next is the WLAN. So it's bigger than WPAN. So uses transmitters to cover medium-sized network. So usually up to 300 feet. Next is the WMAN. So provide wireless service over a larger geographic area. So suitable for providing wireless access to metropolitan cities. So, hence the wireless MANs, wireless metropolitan area networks. So for the largest wireless area network, so we have the W1, so wireless wide area network. So it provides coverage over an extensive geographic area, so suitable for national and global communications. Here we have the types of wireless networks. Now for the wireless technologies, we have also different technologies like Bluetooth, WiMAX, and then cellular and broadband and satellite, broadband. So what differentiates these technologies? So for the Bluetooth, the keyword here is the device pairing process. So it used to communicate over distances over up to 300 feet. So we can also have two types of Bluetooth radios. First one is the Bluetooth low energy and the Bluetooth basic rate enhanced rate, EDR. So the Bluetooth low energy, it supports multiple network technologies, including mesh topologies to large scale network devices. So while this one, it supports point-to-point technologies, and it's optimized for audio streaming. Next is the WiMAX. So it is, the keyword here is the alternative to broadband wired internet connections. So this is the transmitters for my WiMAX. So the WiMAX transmitters and cellular transmitters may share space on the same tower. So shown in the figure here. Next is the cellular broadband. So cellular 4G/5G are wireless mobile networks primarily used by cellular phones but can be used in automobiles, tablets, and laptops. So now we have the 4G network. So 4G delivers speeds that are 10 times the previous 3G networks. Now the new 5G holds the promise of delivering 100 times faster speeds than 4G and connecting more devices to the network than ever before. So the last one is the satellite broadband. So this includes the satellite from the space. So it provides network access to remote sites through the use of directional satellite dish. So that is aligned with specific geostationary Earth orbit satellite. Oops. I just click notepad. Next is the wireless standards organizations. So we have standards for wireless networks. We have the ITU, then the IEEE, and then Wireless Alliance. So I have here this, oops. So here the ITU. So it regulates the allocation of the radio frequency spectrum and satellites orbits through the ITUR. Next standard is the IEEE. So it specifies how a radio frequency is modulated to carry information. So the dominant standards in the IEEE 802 family are the Ethernet and the WLAN. And the last one is the Wi-Fi Alliance. So it is a global non-profit industry trade association devoted to promoting the growth and acceptance of wireless local area networks. So for the WLAN components, we will be discussing this: wireless NICs, wireless home router, wireless access points, and wireless antennas. So wireless deployments require a minimum of 2 devices that have radio transmitter and radio receiver tuned to the same radio frequency. So and devices with wireless NICs. So this is the first one. And devices with wireless NICs and the network device such as a wireless router or wireless AP. So to connect wirelessly, so our phone, our laptop, so they need wireless NICs to connect wirelessly. So however, so some devices don't have wireless NICs, so they can use this device, the USB wireless adapter, to connect to wireless access. Next is the wireless home router. So the home router serves as an access point, and then a switch, and the router. This is the sample image of our router. So most homes have this router. And where are we? And then the access points. So the home router serves as access point, switch, and router. For access points, because we can connect wirelessly. The switch, the home router provides 4 ports for interconnecting wired devices. And also we have the router. So the router provides as a default gateway for connecting other networks to other network infrastructure. So next is the wireless access points. So the wireless access points is another device for connecting, for accessing wirelessly. So it also provides wireless access for end devices. And the last is the wireless antennas. So there are 3 types of wireless antennas. The omnidirectional antennas, such as the one in the figure, provide a 360-degree coverage and are ideal in houses, open office areas, conference rooms, and outside areas. So we also have a directional. So it focuses the radio signal in a given direction. So this enhances the signal to and from the AP in the direction the antenna is pointing. So this directional antennas, so it provides a stronger signal in one direction. So the last one is the MIMO, or the multiple input, multiple output. So it uses multiple antennas to increase available bandwidth for IEEE. So up to 8 transmit and receive antennas can be used to increase throughput. Now for another topic in switch security configuration, we have the WLAN operation. So this includes the 802 to the 11 wireless topology modes, the BSS and the ESS, the frame structure, the CSMA, CA, wireless client and AP association, and passive and active discover mode. So in this first point, the wireless topology modes, we have three types of wireless topology modes, which is the ad hoc mode, infrastructure mode, and tethering. So in the ad hoc mode, so they are connecting wirelessly in a peer-to-peer manner, so P2P manner. So they don't use wireless access points and wireless routers. So in this infrastructure mode, they use routers. There's wireless routers and EPs, or the access points. So in the tethering, they are creating, to two devices, they are creating personal hotspots. So we can refer on this example. So the ad hoc mode is when two devices connect wirelessly in a peer-to-peer manner without using APs or wireless routers. And then in the infrastructure mode, so they are connecting to a router or access points. So this is when wireless clients interconnect via a wireless router or AP, such in the WLANs. Next is a tethering. So it is a variation of the ad hoc topology, and is when a smartphone or tablet with a cellular data access is enabled to create a personal hotspot. So we also have the BSS. So infrastructure mode defines two topology building blocks, so which is the basic service set, or the BSS, and an extended service set, or ESS. So the BSS is interconnects devices in a single AP, while the ESS is the combination of BSS. So here the BSS consists of single AP interconnecting all associated wireless clients. So in this example here, the ESS, or extended service set, so two or more BSS can be joined through a common distribution system called DS into an ESS. So next to be discussed is the 802.11 frame structure and the CSMA /CA. So the frame structure or frame format is similar to the Ethernet frame format, except that it contains more fields. So in this example, we have here the wireless frame. So we have the header, payload, and FCS. Inside the header, we have the frame control, duration, these three addresses, and sequence control, and address 4. So inside the header, we have the frame control. So it identifies the type of wireless frame. The duration, it means that the remaining duration for the next transmission. The address 1 and address 2, it commonly consist of receiving and transmitting MAC addresses. The MAC addresses of receiving end devices or wireless device. The address 3 is the contains the MAC address of the default gateway. And then the sequence control, it is used for sequencing. And then the address 4 is it is commonly missing because it is only used in ad hoc mode. So the payload, it means that the main data that we are transmitting, and the FCS is for error handling. We will also have the CSMA, so or the carrier sense multiple access with collision avoidance. So WLANs are half duplex shared media configuration. So when we say half duplex, so only one device can transmit or receive at any given moment. So shared media means that wireless clients can all transmit and receive on the same radio channel. So it is uh, contradict contradicting. So this creates a problem because a wireless client cannot hear while it is sending, so which makes it impossible to detect a collision. So we use CSMA CA to resolve this problem. So the CCMA is a method to determine how and when to send data on the network. So now for the wireless client and AP association, so for wireless device to communicate over a network, they must first associate with an AP or wireless router. So in this photo, this is the process of associating with the wireless access points. So first, the wireless client need to discover the access points. Then next is the authentication, and the next is the associate with an AP. Okay. So in order to have a successful association, a wireless client and an AP must agree on specific parameters. So these parameters is the SSID, password, network mode, security mode, and channel setting. So the SSID is just the name of this wireless service. The password is used for authentication. The network mode, so it is standard, so A, and then the security mode is for the security parameters, so WEP, the WPA, WPA2. Channel settings is the frequency bands used to transmit wireless data. So next is the passive and active discover mode. So we have in passive mode, it advertises its service. So while the inactive mode, so the wireless clients must know the name of the SSID. So in passive mode, the AP openly advertises its service by periodically sending broadcast beacon frames containing the SSID. Support the standards and security settings. So it's like working with the Wi-Fi. And then the active mode, so the ones who wants to connect with the service, wireless service, they must know the name of the SSID. So next is the CAPWAP operation. We have the introduction to CAPWAP, split MAC architecture, and DTLS encryption. So the CAPWAP, or the control and provisioning of wireless access points. So it is in an IEEE standard protocol that enables WLC to manage multiple APs and WLAN. So WLC is the wireless LAN controller. So in this photo here, the WLC, or the wireless LAN controller, manages these three access points in an IPv4 or IPv6 network. So next is the split MAC architecture. So it is a key component of CAPWAP. This is the concept of split media access control, or the MAC. So the CAPWAP split MAC concept does all of the functions normally performed by individual APs and distributes them between two functional components, which is the AP MAC functions and WMAC functions. So some of the functions for the AP MAC is the beacons and probe responses. For the WMAC functions is the authentication, and then frames translation to other protocols, termination of 802.11 traffic on a wired interface. So next is the DTLS encryption. So it is a protocol which provides security between the AP and the WLC. So this is the keywords. So it allows them to communicate using encryption and prevents eavesdropping and tampering. So we have here the example photo here. So we have the DTLS encryption, so between the AP and the WLC. Now next to be discussed is the channel management, and it mainly involves the frequency channels saturation. So wireless LAN devices have transmitters and receivers tuned to specific frequencies of radio waves to communicate. So a common practice is for frequencies to be allocated as ranges. So such ranges are then split into smaller ranges called channels. So if the demand for a specific channel is too high, the channel is likely to become oversaturated. So the saturation of the wireless medium degrades the quality of the communication. So we have here the three techniques to mitigate channel saturation. We have the direct sequence spread spectrum, or the DSSS. We have also the frequency hopping spread spectrum, or the FHSS, and the OFDM, or the orthogonal frequency division multiplexing. So the main difference between these three is so for the DSS, this modulation technique designed to spread a signal over a large frequency band. So as you can see in this example, this is the original signal, and for the DSSS, it's like I said, it's designed to spread a signal. So here, the signal is now on the large area. Okay, so the next is the frequency hopping spread spectrum. So this relies on spread spectrum methods to communicate. So it transmits radio signals by rapidly switching carrier signals among many frequency channels. So we have here frequency channels. So the main keywords here is the rapidly switching a carrier signal among many frequency channels. So as if you heard it, it is the frequency hopping spread spectrum. So for the last is the orthogonal frequency division multiplexing. So this is a subset of frequency division multiplexing in which a single sub-channel uses multiple channels on adjacent frequencies. So as you can see here in the example picture, we have here the channel end, so it uses sub-channels. So next topic is the WLAN threats. So a WLAN is open to anyone within range of an AP that the appropriate credentials to associate to it. So with a wireless NIC and knowledge of cracking techniques, an attacker may not have to physically enter the workplace to gain access to WLAN. So wireless networks are specifically susceptible to several threats, including, so we have the interception of data, wireless intruders, the DOS attacks, and the rogue APs. So for the interception of data, we need to encrypt the data to prevent this kind of threats. So wireless intruders, so there are unauthorized users that can access our network. So for the denial of service attacks, so it is resulted from maybe improperly configured device, a malicious user intentionally interfering with the wireless communication, and accidental interference. So in the last topic we discussed the WLAN threat. So now we will discussing the secure WLANs. So how do we secure WLANs in the module 12 switch security configuration. So this includes the SSID cloaking and MAC address filtering, the 802.11 original authentication methods, the shared key authentication methods, and authenticating a home user encryption methods, and WLAN. So first, the SSID cloaking and MAC address. So to address the threats of keeping wireless intruders out of protecting data, so two early security features were used and are still available on the most routers, and these are the SSID cloaking and MAC address filtering. So the SSID cloaking, the access points in some wireless routers allow the SSID beacon flag to be disabled. So in this example here, as you can see, we have here the enabled and disabled. So the wireless clients must manually configure the SSID before them to connect to a network. Oops. So the next one is the MAC address filtering. So an administrator can manually permit or deny clients wireless access based on their physical MAC hardware address. So in this example here, so there are two MAC address permitted here. So it means that the different MAC addresses cannot connect to the network. Now for the 802.11 original authentication methods, and so there are two types of authentication methods. We have the open system authentication and the shared key authentication. So for the open system, any wireless client should easily be able to connect and should only be used in situations where security is no concern. So these are the keywords here. Security is of no concern, such as those providing free internet access like cafes, hotels, and in remote areas. So while the shared key authentication, it provides mechanisms such as WEP, WPA, WP2, and WPA3 to authenticate and encrypt data between a wireless client and AP. So for the shared key authentication methods, but first this is the summary of the authentication. We have the open and shared key. So open systems does not requires password, so any client can associate. It's typically used to provide free internet access in public areas. So client has full responsibility for security. So the client can use VPN, so virtual private network. And then for the shared key, we have the WEP, the WEP, the WPA, and then the 2 and the WPA3. Okay, for the shared key authentication methods, we have for the WEP, so the wired equivalent privacy, the WPA, the Wi-Fi protected access, and then WPA 2 and 3. So the main difference between these four is that the security or the encryption methods. So we can say that this one is more secure than this one or this one. Okay. So next is the authenticating a home user. So home routers typically have two choices for authentication, the WPA and the WPA2. So WPA2 is stronger of the two. So we can refer to this sample picture. So as you can see, we have here the security mode. So some choices, we have the personal enterprise. So for 2.4 gigahertz. So the main difference between personal and enterprise is, so the personal is intended for home and small office networks only. So user authenticate using a pre-shared key called PSK. Okay. So the pre-shared key, PSK. So enterprise is intended for enterprise networks but requires a remote authentication dial-in user service, or also known as radius authentication server. So although more complicated to set up, it provides additional security. So for the encryption methods, we have temporal key integrity protocol, TKIP, and advanced encryption standards, or AES. So encryption is used to protect data. If an intruder has captured encrypted data, they would not be able to decipher it, so in any reasonable amount of time. So we have the WPA and WP2A2 standards. We have used the following encryption protocols. So in this example here, we have here the encryption. So we have choices, the AES and the TKIP. So the main difference is the TKIP is the encryption method used by WPA. So while the AES is encryption method used by WPA2. So it is a preferred method because it is far stronger method for encryption. So in this example, what do you think is the network administrator will choose? So obviously he will choose the AES because AES is a method for WPA2. So the security mode is WPA2 in 2.4 gigahertz.